The ISS is the most expensive house ever built in the most extreme environment ever known. A trillion-dollar mega-project constructed across 3 continents over 2 decades and placed into orbit high above the Earth. Looking back from where we stand today, it's almost unfathomable that a thing like this actually happened. It's a floating monument to a fleeting moment in time when world peace seemed so close that we could just reach out and touch it. But that time is gone, and pretty soon the International Space Station will be gone as well. So there's no better time than now before we forget to remember how the world once came together to build the most incredible symbol of cooperation. The first thing you need to know about the ISS is that it isn't really one space station, it's 2. And the process of bringing these 2 sides together would span multiple decades, global conflicts, and the collapse of a once great superpower. It's the late 1980s and the Soviet Union has built the first ever modular space station. A group of interconnected structures that form a habitable platform in low Earth orbit. There are Soviet men and women living and working in space for weeks and months at a time, conducting research and experiments that are expanding humanity's knowledge of the cosmos. They call this station Mir. Now, there are a few different English interpretations of the word Mir. It can mean world, community, or village, but it can also simply mean peace. Meanwhile, the Americans have a space shuttle. It's a very impressive machine that can fly to space and do amazing things, but it's got nowhere to go. American astronauts simply go up and then they come back down again. But the Americans also have a plan, and they call it the Freedom Space Station. Bigger and more advanced than Mir, the American space station was first called for by President Ronald Reagan in the early 1980s. Construction of Freedom should have been well underway by the end of Reagan's term in 1989, but as the decade drew to a close, there was little to no progress to speak of. And at the same time as all of this, one of the most significant events in modern history was taking place: the fall of the Berlin Wall, the beginning of the end for the Soviet Union. Now we'll skip over a few years of turmoil as the old Soviet Union dissolved and the nation of Russia was reborn into what we know today. By the year 1993, the American and Russian governments were talking seriously about cooperation. The hatchet of the Cold War had been buried and replaced by an olive branch of unity, East and West working together for the betterment of all humankind. It didn't hurt that the Russians had inherited a fully functioning space station, and the Americans still very much wanted to build a space station. But at some point, they had to admit to themselves that they just couldn't do this on their own. So the US government invited Russia to become a full partner in a new program, the International Space Station. Step 1 would be to open up Mir to an American presence. In 1995, the space shuttle docked to the Russian station for the first time. Astronauts and cosmonauts worked together on scientific investigations and medical studies in space. As a symbol of peace and unity, this was huge. But from a more practical standpoint, this was the beginning of an opportunity for NASA to quickly learn as much as they could about how this space station worked and then try to figure out if they could replicate the technology. Short answer was that they couldn't, or at least that it couldn't be done in a reasonable amount of time for a reasonable amount of money on American soil. On the other hand, the Soviets had already been well into the process of planning a Mir 2. They already had the industry and infrastructure in place from the first Mir construction, and they'd even built a new core module. But that whole thing with the death and rebirth of a gigantic nation had left Russia a little short on cash. So here is the deal that was struck. America would pay Russia to build the core of Mir 2 Zarya, containing the power, propulsion, and life support systems. The beating heart of a new space station would be all manufactured in Russia using Soviet technology. Now, it's important to make that distinction between Russian and Soviet because much of the Soviet space program was engineered by ethnic Ukrainians and other smaller nations that found themselves behind the Iron Curtain. When those borders were redrawn in the 90s, Russia ended up with a lot less access to those Soviet resources. So half of the ISS, arguably the most important half, would initially be controlled by Russia, yet owned by the USA. And the other half would be a collective effort between NASA and their closest partners. America would build 2 core modules, Unity and Destiny, while the European and Japanese space agencies would each contribute their own research laboratories, Columbus and Kibo. And the Canadians, they built an arm. Zvezda means star in Russian. This was the first to be built by a pretty wide margin, actually. This was the module originally constructed for Mir 2 that Russia had inherited from their Soviet predecessors. Work on Zvezda began at the Khrunichev Design Bureau in Moscow in 1984, and by 1986 it was pretty much complete. After that, the module was put into storage where it would wait for 14 years before being called into action for the ISS. Zvezda does two important jobs on the space station. Number one is to provide life support. The systems regulate the temperature, pressure, and humidity of the station's environment. The system also generates oxygen from recycled wastewater. Number two is propulsion system. It plays a critical role in maintaining the orbit and orientation of the space station. It's fitted with two orbit correction engines that prevent the ISS from falling down into Earth's gravity, and there are 32 small thrusters that control the exact position of the station. The first module of the ISS to be launched into space was the Russian Zarya, meaning sunrise. This was a construction project funded by the USA, but manufactured by Russian contractors in Moscow, which cut the price in half compared to a made-in-America option. Construction of Zarya took place from December 1994 to January 1998, also at the same facility where Mir had been built a decade before. Zarya launched on November 20th, 1998, atop a Proton-K rocket from the Baikonur Cosmodrome in Kazakhstan. This event marked the beginning of a new era in space exploration, a transition from Cold War competition to peaceful cooperation. After 16 days spent alone in space, Zarya was met by the first American module of the ISS, Unity. This design also has roots in the mid-1980s. The American modules were conceived as part of Reagan's Freedom Station. The Unity module was constructed between 1994 and 1997 at Boeing's manufacturing facility at NASA's Marshall Space Flight Center in Huntsville, Alabama. True to its name, Unity would function as a central hub for integrating ISS modules from different nations. It also serves as an essential routing point to distribute resources throughout the station. Unity contains over 200 gas and fluid lines, plus 121 electrical cables spanning 6 miles of wiring. When Unity finally met Zarya in December 1998, there was still one big problem to overcome. The Russian modules had been built with the classic Soviet docking port, which was round, while on the American side, Boeing had developed a square docking port. So there was one more critical piece of equipment required: the pressurized mating adapter. NASA's answer to fitting a square peg in a round hole. Strange as it might sound, the Space Shuttle docking port was also built in the round Soviet style. That's because it was originally designed for docking with Mir. So the American modules of the ISS also required an adapter to dock with their own space shuttle. Unity was launched aboard Space Shuttle Endeavour on December 4, 1998. 2 days later, it met up with Zarya in orbit, where the shuttle's Canadarm grabbed Zarya and pulled it into dock with Unity. Following that, a spacewalk was done where shuttle astronauts set about the task of integrating the two modules together. But this was still not a habitable station, so once the integration was complete, the shuttle released the paired modules into orbit and the crew returned home. It would be nearly 2 years before the first phase of the ISS was completed with the arrival of Zvezda in July 2000. The Russian core module was launched to orbit on their own Proton rocket, and in a story that could only happen in the early 2000s, that rocket carried a Pizza Hut advertisement with it to space. It was reported that the company paid $1 million to have their logo incorporated into the historic rocket launch. The money went to support the production of Russian spacecraft. After 2 weeks in orbit, Zvezda had caught up to previously orbiting components of the ISS, and using its advanced propulsion system, Zvezda was able to autonomously dock itself with Zarya. With the power, propulsion, and life support systems in place, the ISS was finally ready to receive its first crew. On October 31, 2000, a crew of 3 lifted off from the Baikonur Cosmodrome in Kazakhstan aboard a Soyuz spacecraft. 1 American and 2 Russians. In February of 2001, the crew was joined by the space shuttle Atlantis, which brought with it the second American module, Destiny. Destiny brought science and research capabilities to the ISS for the first time. Like Unity, it was manufactured by Boeing in Huntsville, Alabama, at a cost of $1.4 billion. Destiny also marked a turning point in control of the space station. With the American side now fully operational, command of the ISS was officially transferred from Russia to US-based mission control. This was the beginning of continuous US-led scientific operations in Earth orbit. The next important component to arrive at the ISS wasn't a module. It was a tool, the Canadarm2. Canadarm1 was integrated into the Space Shuttle cargo bay and had been used extensively in the first phase of ISS construction. Canadarm2 was designed and built by MDA Space in Brampton, Ontario. It's made from titanium and carbon fiber with 7 motorized joints. The Canadarm would play a major role in Phase 2 of ISS construction, building out the station's giant truss structure and solar panel array. Before they could expand the internal volume, they first needed an abundance of power being generated. Construction of the truss and solar array would go on for the next 5 years, from 2002 to 2007, and this set the stage for the arrival of the next key module, Columbus. This module also traces its origins back to the mid-1980s, when the European Space Agency had been planning its own space station program under the name Columbus. After the merger of NASA's Freedom Station with Russia's Mir 2 program, Columbus became a major contribution to the ISS, designed to provide Europe with permanent access to orbital research. Columbus was primarily constructed by Thales Alenia Space in Turin, Italy. It was then shipped off to Bremen, Germany for installation of the electrical system. Then it flew across the Atlantic in an Airbus Beluga cargo plane before finally being integrated into the space shuttle Atlantis and launched to orbit in February 2008. The next module to arrive would be the largest on the ISS, Japan's Kibo Research Facility. The name, chosen in a public vote by the Japanese people, means hope. This again traces its roots back to the 1980s, when Japan also had dreams of their own space station. That quickly transitioned into a partnering role when the ISS was announced. Kibo was built by Mitsubishi Heavy Industries at the Tsukuba Space Center in the suburbs of Tokyo. It is the largest of the ISS modules, so large that it had to be broken up into 3 segments that were flown to orbit on separate shuttle missions. It took over a year to deliver and install the Kibo laboratory. It has its own airlock, robotic arm, and an external platform for conducting experiments in the vacuum of space. The final core module of the ISS actually traces its origins back to the very beginning of American and Russian partnership. When the US commissioned Russia to build the Zarya module, they included the construction of a backup, a second shell module built just in case something went wrong with the first launch. So because Zarya was a success on the first attempt, the Russians were left with this empty space station module just kicking around. In 2004, Russia decided to convert the partially completed backup into their own research laboratory. You may have noticed by now that all of the high-tech research facilities are located on the American side of the station, while the Russians are primarily occupied with the logistics of space station operations. The Russian laboratory would be called Nauka, which means science, and in spite of their head start on construction, the Nauka module would arrive very late to the party on the ISS. Originally targeted for launch in 2007, technical issues and funding problems caused a 14-year delay. Nauka finally lifted off from Kazakhstan in July 2021, and now, almost as soon as it is actually completed, the powers that be are talking about the end of the ISS mission. Elon Musk wants it destroyed ASAP. NASA is planning a full retirement around 2030, when they'll push the entire structure down to burn up in the atmosphere, and what's left will sink into the open ocean. Meanwhile, the Russians, Europeans and Japanese have all expressed interest in preserving their own segments of the station, with the idea that